Hey guys,
Hello!
what do you got here, Eddie?
Well, it looks like we're finally getting back to our RGB LED project.
Quest for the RGB LED.
Indeed. And, as an ocean is made up of many drops, so an RGB LED strip is made up of many RGB LEDs.
Electroman Jade donated to the show a cool little strip of serial addressable RGB LEDs. But before Addie learned how to use it, she wanted to learn about all the fundamentals that went into its construction, so she is basically building her own from scratch and
Well, kind of.
learning how it works on the inside.
Yep, so we start with Uno, right here. And
That's not a normal LED, is it?
no, it's an RGB LED, and it's got 4 prongs, one for red, one for green, one for blue, and a ground. And essentially, it's 3 LEDs in one package.
Yep.
There's nothing like magic. Well, I mean, it is magical, but there's nothing super magical about it. Different resistors for the different colors, and that black wire is just random. So,
Yeah.
and we're doing
The
this.
green one's running ground over for the back side of the LED.
Correct. And this is being done on a propeller demo board because it's amazing. So, oops. Okay. This is the power cord. That's the serial
Programming
programming
cable.
cable. Yep. So, let's get this on a configuration it actually likes. So the first thing Whisker had to talk to me about was pulse width modulation, which I think is a very hoity-toity way of saying making these LEDs blink.
Addie became very grumpy about pulse width modulation today.
Because it's pulse width modulation, didn't you know? Blah, blah, blah. So, whatever. Anyway, so here's an explanation.
In the end, I think I managed to show her what was going on.
So we hope. So it's got kind of to do with duty cycle.
Sure.
So duty cycle is the idea of the percentage of something that's on over the total amount of time. So it's that ratio. And so here you can see that when the signal is up, like say this is the 0 line, and this is 100% from here to here, you see that the signal is on 50% of the time. And then you see here, if this is from 0 to 100%, you see that the signal is on 75% of the time. And here you see that 0 to 100%, it is on, the signal is on 25% of the time, and that would be its duty cycle: 50%, 75%, 25.
Now, color tends to be encoded 8-bit anyway, in 0 to 255. Okay. So instead of doing percentages, we're doing a number 0 to 255 as our 0 to 100%. So 255 would be our 100%, and 128 would be our 50%.
128. So if a number, if say your R value, G value, or B value is less than 128, then the signal is off.
For half.
For half of the time.
And on for half of the time.
And then if it's greater than 128, then it's on for half of the time.
So I helped Addie write this little PWM function that basically bit bangs this out manually.
Now can I ask something? If you did 25% duty cycle with the RGB values, would that save battery power?
Yes, because you're only sourcing for 25% of the time.
Oh, I see. So it's like the light pulses for 25% as opposed to 50%.
Yes.
I see.
Now, keep in mind, LEDs don't turn immediately on or immediately off. They have a little bit of, I guess you could say, smoothing effect
Okay.
on this. So you're not getting appear on off, you're getting more of a swoop up, swoop down, swoop up, swoop down. But it's happening so fast that the human eye just sort of sees it as one constant color.
Sure. So we actually have here going, aquí, we have here the 50%.
Red?
50%, yep. And it's going, so I set red to be 255, and that means that for 50% of the signal's total time, it is on for 50%, correct? Is that about right? Okay. So we wanted to be able to individually access these colors. So here's it when I have it off, or when everything's 0. You see, guys saw red already, so I'll do green here. Bam! And then we'll do blue, and that looks like this pretty. Excelente. But you know, like, that's only one color at a time, and so I wanted to make it cooler, and I wanted it to be able to fade in, fade out, fade in, fade out. And so I'm not exactly sure why it starts out like that, but so it goes blue, then red, and green, blue, red, salmon, green. Yeah, so that was kind of cool. And then and that actually taught a lot about extra variables, and we actually
and at this point Addie's, you know, put all the code together herself. I mean, with a little bit of help, obviously.
Yeah.
And then I think for the next step, she asked if I could help her make something that could fade from any single color to any other color.
Yep.
More complicated colors.
Yep. And so not just the 255s.
Yeah.
And so,
stuff in the middle.
Right. So I decided to do Roy G. Biv for
I see.
For the rainbow. Now the colors orange and indigo didn't really turn out, but if you look at my hand, you can see that. Can you see the difference? B I V R O Y G B I B. Okay, but if you look at it, it's like, it looks almost exactly the same for some of the colors. And apparently that's why some TV companies have those 4-color TVs to like help with the change. I don't know. But
no, those 4-color gamut things, that's a crock.
Oh.
Don't even.
Crockpot. Okay.
Yeah.
So anyway, so this is the super cool rainbow color effect of the RGB LEDs, and I think, let's see, yeah, so that's like one, but now I have to individually address like a whole crap ton of them.
Yeah,
correct.
And I think the next thing we might do is teach you how to control this thing over serial connection. And that'll be pretty fun.
Okay.
All right, so until next time, we'll be out there doing all the other stuff that we do. Zombie Tech coming out in a couple days.
Yep.
First Spin coming out later today.
Yep.
So, you know, go check those out. ZombieTech.tv, FirstSpin.tv. So our podcasts. We appreciate you guys going over there and checking those out.
Yes.
So we'll talk to you guys on Friday.
Bye.
Bye.
We post videos all the time, so don't forget to subscribe. And follow us on Twitter at TYMKRS.